Hey everybody, welcome to PC Perspective. I'm Ryan Shrout with Alan Malventano. We're here to talk about a cool little project we've been working on for the last longer than expected. This is a, I don't know what started it, what brought it about. Was it the motherboard or was it the SSDs or was it the...
No, it was the motherboard came out. I saw the announcement come across and I'm like, hey.
We saw this motherboard. This is the Gigabyte, what is this board exactly?
SOC Force.
Yeah, the Z170 SOC Force motherboard. This is a brand new product, and what was interesting about this is that, as you can tell from this shot right here, it actually has 3 M.2 slots
built into the board. Yep.
Built into the board. You don't have to have riser cards or anything like that.
Yep.
And they rest neatly between the 4 PCI Express slots.
Yeah.
It's pretty neat. It's actually an excellent design.
It is.
Aesthetically, pragmatically, all that stuff is there. And what's interesting is that we found out that not only does it have those ports on there, but you could use all of them at the same time.
All at the same time. Well, it'd be silly if you couldn't.
Well, yeah, that's true. But they also have full bandwidth.
Well, they have full bandwidth up to the capacity of, like, they're all behind DMI.
Okay, yes.
Right? They're all behind the chipset.
But yes, okay, so the chipset to the processor bottleneck is still there.
Yes.
As it turns out.
But that's also an advantage because you can do RAID across all of them within, like, set it up in the BIOS, and you can have a RAID of those 3 M.2 SSDs that are PCI and NVMe and all that stuff.
Clearly that's what Gigabyte wants people to do, because there's not really a reason to have more than one M.2 slot on a motherboard if you don't expect people to do RAID, unless you're going to have one for your OS and one for storage. You wouldn't do that, right?
Yeah.
And we've seen like MSI has done things with their gaming notebooks, for example, where they have 3 M.2s all running in a RAID 0. So this is something that people want to do. They're trying to do.
And back when this was first a thing, we tested that Asus, that first Z170 board from Asus, where you were kind of limited on what you can do, right? You had to use a slot for one.
We used an Intel 750 series slot, and then we used the U.2 connector for the second one.
Right, so you had to kind of like mix an M.2 and a PCI slot if you wanted to be able to do a RAID. And the only people that have, like, the only company that has products that are the same product in those 2 different form factors was the Intel 750 specifically. So it's like you're really limited on what you can do a RAID with on the early boards, right?
So essentially, we saw this board, we saw that it could support 3, we're like, well, damn it, let's just do that. So we asked Samsung to send us a couple of more of their 950 Pros.
Yep.
So we have 3, what capacity are these actually?
512.
So we've got 3 512 gigabyte 950 Pro M.2 SSDs in here, so you got a 1.5 terabyte RAID 0 array. What is the setup process like? You go into the BIOS/UEFI on this board, and it's not as simple as it should be.
It's still a little tricky. It was tricky back in the beginning when we tried this for different reasons. You have to make sure you find all the random switches within the BIOS that are, and once you've figured out the right switches, then magically you will get like an extra option which talks about setting up the RAID. And you actually set up the RAID within the BIOS. You can also set it up within Windows if you have Intel's RST driver installed.
So if you had a SATA drive set up for your OS and you wanted this to do something else, for example, you could do that.
You could, yeah. Or I believe you can even like add drives to it on the fly.
Oh, really?
So if you had a single M.2 and you had the RAID driver installed, and you'd have to have everything configured the right way at the beginning.
I see.
Kind of like how with SATA drives, you have to be in RAID mode at the beginning.
Right, otherwise it screws up your Windows install and all that stuff.
Yeah, so you should be able to like add on drives on the fly, stuff like that, which is cool.
So you create the array in the BIOS, and then you start Windows installation. Does it see it automatically? Do you have to install a driver? How'd that work?
For this one,
remember, I think the
installer sees it.
I think the installer just sees it.
Yeah.
Right.
Windows 10 installer sees it.
Right. Yeah, we are using that.
If not, it's not that big of a deal. You just get the current RST driver. You just get the floppy. They still call it floppy.
That's crazy.
But just the very small INF version of it.
Right. Put it on a USB drive when you get to that spot.
You can even put it on the USB installer, just in a subdirectory.
Right.
And just point the installer to that directory, point it to the driver. Then it'll see the drive.
Okay. Then you can just install Windows to it like normal. And then you can monitor it through the RST software and all that as well?
Once you get into Windows, you have to install the full-blown RST, and that gives you the console where you can see it, and you can modify caching settings and stuff like that.
So let's talk about performance. What is it, when we did a review of the first 950 Pro, what is a single drive kind of doing reads and writes? If I'm just talking about megabytes per second, or gigabytes per second, I guess.
Gig and a half writes, 2.5 gig reads.
Okay. So quickly, what does, like, impress me. What does this do?
So as you add drives,
yeah, basically, if I go to 2 950 Pros in RAID 0, what do I get?
2 of them is pretty much enough to saturate the DMI link.
Okay.
Both directions.
Okay.
Right. So you were basically almost saturating DMI, because the saturation point is like 3.5 gig per second.
Okay.
Or so.
All right.
So I mean, you were already at like 2.5.
Okay.
So you're
getting
really
that
close.
Are you getting the 3.5 gig reads with 2 drives?
Yes, you can hit the 3.5.
And then what do you hit on writes?
It's right at 3.
So you're getting 3.5 gigs per second read, 3 gigs per second write. Okay. Now what happens if we add a third one in?
You don't actually get much more.
Really? Even on writes? Do you get that 3.5 on writes? Can we get that last 500 megs per second?
No, not really. Well, it's like, it's basically 3.5. You have overhead and everything else.
I know.
That you're not going to get the perfect, 4 or
so with
that
3 in Addo, what did we see reads and writes?
It was still the same. It was like 3, just over 3 on writes, and like 3.3 gig per second on.
Okay, so 3.3 gigs per second read, 3 gigs per second, right? That's pretty good. It's acceptable performance, I think. But there was more interesting than just throughput. You had one kind of neat discovery about
what I wanted to try to be able to demonstrate, which was specific to this platform. Like when this came out, the thing that popped into my head, wow, this would be great to demonstrate this.
Right.
Was why RAID systems, even though you don't necessarily get higher throughput, the same applied for SATA back in the day, where you had you were limited to like 600 meg per second on like X58 chipsets, right? But if you did a RAID of 4 SATA SSDs, even though you bottlenecked the chipset, after the second one,
right?
There was still a difference in snappiness, and the system just felt faster,
right?
You knew that you were hitting a bottleneck after just the second SSD,
okay,
but something made it feel faster.
So what is that?
And that thing is actually easily shown by our latency percentile testing, which is the new thing we introduced back when we did the single 950 Pro review.
You say easy to show, maybe easy to show, still not easy to understand necessarily, so keep it high level for
right.
Here.
Well, the idea is that this is actually a thing we can show on a chart now that is, in my mind, as close as you can get on a chart to the feeling of the faster system.
So what changes as you add drives, even though you're not seeing dramatic throughput improvements?
The easiest way to explain it in real simple terms is if you start with just a single drive, as you load that single SSD, right, the IOs take longer and longer to be responded to. Okay, if you were to look at all of the IOs over a certain amount of time, right? Because as you add more layers to the queue, it just takes, some of those IOs take longer and longer and longer to
That's because they're physically waiting in a queue.
They're waiting in a queue, right? And another thing is that once you get past a certain point with most SSDs, that profile kind of changes. It tries to, most of them get responded to within a certain amount of time, and maybe a few, relatively small percentage of them will take a little bit longer, right? But that line kind of just stretches out.
Right.
Also, right? So the majority of the IOs are actually taking much longer, right? So the idea is the closer you can get, it's basically exponential worsening as you increase the queue, the queue depth and the load on a specific SSD, right?
Yeah.
So now if you take that bit of knowledge and you apply it to, okay, well now I can spread that load out over multiple SSDs. So if the system is doing the same amount of hard work, relatively hard work, but you can spread it out over multiple, then each individual SSD sees a fraction of that work, of that load. And then that makes that profile much closer to the ideal, which is where everything is being responded to very quickly.
Right.
And not spread out over certain variants in time.
So as you look at the graph that shows this data, what do you want to see ideally? What is the impressive part? The line goes from a...
Well, there's 2 things. You want it to be as far to the left as possible, because that's low latency.
Low latency.
Right? And you want it to be as vertical as possible. In other words, all of the IOs...
So that all the IOs are consistently low
at
latency.
That latency, right?
Okay.
If it gets spread out, that means, well, some of them are...
taking longer.
Taking much longer, right?
Okay.
It's even with some of the worst case things, and I'm only considering queue depth of 16 as worst case here, which is not really that high. That's within power user, they can hit that high of a queue depth. some of those IOs go all the way out to like 1 millisecond. And considering this is an SSD that's like within the 20 nanosecond range for an IO,
right.
If you stretch it all the way out to a millisecond, that's a pretty big stretch, right? I mean, like hard drive is in like 9, 10, 15 milliseconds. You have an SSD that's supposed to be super, super fast, and some of those IOs are taking a millisecond.
Okay.
Relatively long time, right?
So we add another drive, or 2 more drives, and we can jump to.
Another drive, or you add a third drive, and then as you do that, with the same overall load to the array, in other words, you're doing the same stuff on the computer,
right.
It makes that profile just progressively more vertical. You know, there's still a little bit of IOs that are going to take a little bit longer over time, but you can see that there's an obvious change in the way that curve looks as it changes from single drive to 2 drive to 3 drive, which is actually right there.
Yeah.
Right? It just basically becomes much more vertical, and there's much less IOs that are taking a longer period of time, which is the kind of thing
so
that
this is what you're saying relates to the snappiness feeling that you get, even though you may not see an improvement in bandwidth per second.
Right.
The responsiveness of applications.
Yeah,
may improve.
because I mean, you can hit like the same IOs per second figure. We actually have those charts, which I'm going to include in the review. Like the IO per second ramp up thing, a thing we used to include in all of our regular SSD reviews. Right. It looks so similar for the majority of that chart that you can't even really see a difference between.
So you would think
lines.
that your performance improvement going from 1 to 2 or 2 to 3 drives is actually minimal.
So like, yeah, it's okay. It's going to be the same. You know, sure, you can get to a higher number of overall IOPS, but you have to get to a much higher queue depth
for that to matter.
Right?
Less likely for power users.
Right.
Consumers.
And so if you looked at just either an average latency output or just an overall IOPS output, you would totally miss the thing that we're showing in our new charts.
Yeah.
Because we're actually looking at every individual IO and able to plot them out over a span like that. Which is cool, right? It's something you can discover that we couldn't discover before, which is kind of like what our whole thing we want to do here is.
Right. Well, and we've talked about this when we did the first review. It's very similar to like how frame rating discovered difference in latency of frame times versus...
Exactly. You had your FPS.
Yeah.
Like this is the same kind of thing, right?
Same idea.
This is the variance.
It's very cool.
Of those.
Is it any different in writes versus reads?
Writes, okay, so there's 2 other big things we discovered here. First of all, if you do a RAID at all, like single drive versus any RAID, you get a 6 nanosecond penalty per IO.
Okay.
It's not that much time.
Yeah.
But hey, it's something that is actually very easy.
And that is just going through the logic of determining which drive it needs to talk to?
Yeah, it's like it has to go through an extra layer of software, firmware, something.
Okay.
Right? And it takes 6 nanoseconds for each IO just to go through that stuff, right?
All right.
That's almost immediately countered by the fact that most of the IOs are going to be much faster by adding that extra drive, right?
Okay.
But, just something also able to determine from our output.
Neat.
And also on writes, the difference was much more significant than on reads. On reads, the drives tend to be very tightly together. You can see, yes, there is still some of an advantage as you go up, but it's much harder to see that advantage versus writes. And also on these drives, and actually most of the PCIe NVMe drives in particular, the writes will be much less latent than the reads. Like the SSD has to do much more work to turn a read request around.
We talked about this before. You explained it to me as when you give it a write, you just basically say, here's the data, and the application can move on. Because it's the controller, the SSD, and
it has it in a buffer
figures
somewhere,
out where it's doing,
like
where it's
almost
going to go.
immediately, yeah. So
when you're reading it, you have to wait for all that logic to complete before you actually get the data out.
It has to look up, where is it,
so
has to retrieve
that kind of makes sense. Okay.
Yep. And I think that's also part of the reason that the writes is so much of a greater difference, right?
Sure.
Because you're operating in a much faster region, a much less latent region in the first place, so differences are going to be that much more obvious.
So, anything else like power-wise? Like these things can get pretty warm. We saw, but power consumption-wise, we don't know if they're really. I mean, if you're buying a $400 motherboard,
they draw
it's
6
like
watts each.
Oof, man, that's 18. That's almost 20 watts total.
Fully loaded, they draw 6 watts each.
Okay.
I will say this: if you're going to run these, I did notice that this first SSD, we had like an NVIDIA GPU installed, like a 970 or something, and the first drive was running like 20 degrees cooler than the last drive under load. Yes, it was actually running cooler, even though there was a GPU right on top of it, because the fan for the GPU was actually drawing air across.
We were using a non-blower fan cooler on that, weren't we? We were. Yeah, we were using an EVGA.
It was a regular.
So, yeah,
it had
two fans on
out
it.
the top and the bottom. Yeah.
I wonder if you had a blower fan, if that would be reversed.
Maybe
because there's no airflow externally from the graphics card. So something to keep in mind.
That is something to consider, and also. My argument to some folks is, well, just like get one of the stick-on heat sinks, put it on the controller, because that's the part that gets the hot part. There's actually not really enough room on this
not
to do
enough height for that.
Because the GPU, it was like maybe an eighth, 3/4, or like 3/16 of an.
I mean, if you put this in a case with some airflow across it, right? It's probably going to be better, right? You've got fans coming in the front here; they're going to be blowing across the GPU area, so that's not.
But there's another couple of good things to consider. If you're going to do 3. And your loading is the same overall. The drives are only loaded 1/3.
They're only doing a third of the work.
They're only doing a third of the work, so it's actually very hard to get them to throttle. I was trying to get them to throttle in this configuration with no fan blowing over.
Right.
And like whenever it did drop, I mean, it only dropped about like 100 meg per second out of like a 3 gig per second overall.
3.3 gigs.
Yeah.
So okay. End of discussion here. Let's ask, should people do this, right? So this is the only motherboard we know of that exists that does 3 drives.
Right.
And it's a $400 board. It's a very expensive board, but there are more boards that have 2.
There are.
Out there that are much less expensive. Is this something people should do? Like if you're going to buy an M.2, does it make sense now to buy, if you're going to get a 1 terabyte, buy 2 512s. If you're going to buy 512, buy 2 256s, put them in a RAID 0 and do it that way.
The thing you have to consider is that as you add M.2 drives to this particular board, you start losing the Intel SATA ports.
That's going to be the case on any motherboard almost.
Right, but now you have 3 of these, which means you end up with 0 Intel SATA ports remaining.
Right.
So you only end up with the ASMedia controller, which only gives you 2 SATA ports.
Right. That's interesting. So normally you would get 6 SATA ports.
Right.
From the Intel chipset, from the Z170 chipset, and when you're using all 3 of these, you get 0.
Yeah.
And you may even lose some USB 3.1.
I'm not sure. I think it's just SATA.
That's a lot of bandwidth.
But that's how it's getting that bandwidth back. Is it's just reallocating all of those SATA channels.
So that is something to consider. And if you're buying a motherboard and you do 2 of them, you're gonna lose something, right? And that's gonna vary motherboard to motherboard because it's all about the implementation.
You'd at least lose 2 of the 6 Intel ports.
Yeah.
Still leaves you 4.
That's probably fine. But if you've got 2 SATA,
if you're gonna get this one, I don't see how a person would get this and just be staring at like a blank M.2. Like if you get this and you're gonna do a RAID, you're probably gonna buy 3. It's just asking.
You would buy 2 256s or something like that to save.
You could.
Yeah.
Maybe.
No, I'm saying 3 256s is what I would get if I was going to look at that. Yeah, if you have this board.
Right.
That's what you should do, clearly.
If you want a board that you're not worried about hanging a lot of other hard drives off of, like you have a good network storage and you just want really, really fast main partition storage, like that's, I mean, you can't go any faster, really. Like,
it's such an interesting product. Like the SOC Force is supposed to be Gigabyte's like best overclocking product.
Yeah.
It's got like integrated water block on the power delivery circuitry here.
Yep.
And then it just throws in 3 M.2 slots as well. It's a really interesting product. Maury has a review of this board up, right, already? No, we're sending him this after we're done. We have to send him
this one,
so he can do a review of this board. But a pretty unique product. But like I said, the idea in general is that, hey, M.2 SSDs, if you have the option to do it, RAIDing presents a lot of benefits.
It does now that it's a thing.
Yeah.
It didn't used to be.
Yeah, that's true.
Yeah.
And it's still, this is maybe the second NVMe drives out still, right? If we take the Intel 750 as the first, this is still really it, and really the most popular one, I think, by far.
It's true. But as we saw at CES, there's a whole bunch of other M.2 NVMe
coming up.
SSDs coming out. So you're going to have like your pick of what to put in that RAID.
Very cool.
Yeah.
Obviously, we have the full review up on PCPer.com. You can see all of Alan's explanation, all of the additional graphs. We showed some of them to you here, but if you need more help kind of like understanding what those mean, he does a better job in the story kind of detailing what this is, and like here's a graph and here's a zoom in of a section that is very important of it as well. And we want to thank Gigabyte for sending us this motherboard to play around with and do this, and thank Samsung for sending us the SSDs to mess around with this project. And as it turns out, we actually learned some really cool stuff about IOs and latency and why things feel the way they do when you're using a multi-storage array system. So very cool. Thanks, guys. We'll see you next time.
Thanks.
If you enjoyed this content, consider supporting in-depth technical content by contributing at patreon.com/PCPer.